everybody, it's Mrs. Tremblay. It's time for lesson 4.4. We're still in systems, but we're going to talk a little bit about special cases. And all the methods that we have used to solve systems, there's always been one solution. And what I need you to understand today is that sometimes there are no solutions to the system, and sometimes there are infinitely many solutions, meaning that any ordered pair that you plug in there, it's going to work. So our objective is to figure out when there is a special case. So just a little review right here. One solution, the lines intersect. So when the lines cross, we have different slopes. You should jot that down. When you see a set of equations that have no solution, it's because the lines are parallel. Parallel lines will never intersect, and if the point of intersection is where the answer is, and they're never going to cross, that means there's not going to be an answer. So to recognize this, if you weren't looking at a graph, when you look at the equations, they would have the same slope. They have to have the same slope, but the y-intercept should be different. Alright, finally with the infinitely many, I know you can't really tell by looking at it, but there are actually two lines here. One line is right on top of the other. Why? Because they end up being the same exact equation, meaning they have the same slope and the same y-intercept. And that means that they are the same equation. Alright, so different slopes, that's what you're used to. Finding one solution is where they cross. No solution means you have two parallel lines. Parallel lines mean same slope, different y-intercept. Infinitely many means you have two of the exact same line. One line right over top of the other. The point of intersection is every single point on the line. Alright, so we're going to look at the same exact system all three ways, solving it all three ways, so that you could recognize what to look for in your solution no matter how you're solving it. So I have the system 2x plus y equals 5 and 4x plus 2y equals 0. The first way I want you to solve this is by graphing. So when you look at those equations, they're not set up nice and pretty to graph them, so let's set them up nice and pretty so we can graph them. So 2x plus y equals 5. I'm going to need to subtract 2x from both sides for this one to get the y equals version of it. So it's going to end up being y equals 5 minus 2x, or 5 plus negative 2x. In this equation here, there's a little bit more work to do. The first step that you would do to get the y term alone is add a negative 4x, or subtract 4x, however you look at it. So 2y would equal 0 minus 4x is just negative 4x. We would divide by 2, and you get y equals negative 2x. Now, at this point, if you can see that, hey, I have the same slope but two different y-intercepts, you might recognize that as, oh, these are two parallel lines, there's going to be no solution. If you don't see that right away, that's okay. We can graph it. So the first equation, y equals 5 plus negative 2x, the y-intercept would be 0, 5, and then a slope of negative 2 means down 2, right 1, down 2, right 1. So there's our first line. If we're just graphing y equals negative 2x, that means my b, my y-intercept is 0, 0, and I go down 2, right 1, down 2, right 1. And you can keep doing that forever and ever and ever, but no matter how long you do that for, you're going to see these are parallel, they're never going to cross. So this isn't enough to just leave it like this. You actually need to write the words, no solution. No solution. Okay, now I've given you the exact same set of equations here just so that you know how to recognize it no matter how you're solving it. So here's the same exact system. Let's solve this by substitution. So if we're going to solve this by substitution, that means that I need one of these solved for y. We already did that over here. We rearranged this first equation into y equals 5 plus negative 2x. So if y equals 5 plus negative 2x, we're going to plug that into this y. So it would be 4x plus 2 times 5 plus negative 2x equals 0. We get 4x plus 10 plus negative 4x equals 0. And wow, look at this. We have 4x, we have negative 4x. Those cancel out, and we get that 10 equals 0. Our variable is gone. Does that make any sense? No, it doesn't. And 10 doesn't equal 0, does it? So that's how you could recognize, if you weren't graphing it, that this is something that doesn't have a solution, because the variables have canceled out and the statement that's left is not true. Okay, let's try to do the same one using the process of elimination, just in case that's the method you would choose to use. So in looking at these two equations, I don't know, we could eliminate the x's, why not? And if you eliminate the x's, I would need, okay, well, 2 times 2 is 4, and I need it to be negative. So I would multiply that whole equation by negative 2. So my new equation would be negative 4x plus negative 2y equals negative 10. My other equation would remain the same, so 4x plus 2y equals 0. And when you go to add these up, the negative 4x and positive 4x cancel out. Negative 2y, positive 2y cancel out. I'm left with 0 plus 0, which is 0. And 0 does not equal negative 10, does it? So again, if everything cancels out and you get a statement left that's not true, that means there's no solution. So that's how you could recognize it in all three ways. Okay, so that's when there's no solution. Take a look at the next one. So turn your page. Same thing, here is your system. The first thing I want you to do is solve this by graphing. So to rearrange this equation, the x minus y equals 8 equation, I would go ahead and add a negative x to both sides first. You end up with negative y equals 8 plus negative x. To get rid of this negative in front of the y, remember that means it's a negative 1. We're going to divide all of our terms by negative 1. So y equals negative 8 plus positive x. That's our first equation. And in our second equation, the y term is already by itself. It looks like all we need to do is divide everything by the 2 that's in front of it. So that equation would end up being y equals, and then 2x divided by 2 is just plain old x, minus, and negative 16 divided by 2, that's a negative 8. So I get y equals x plus negative 8, and y equals negative 8 plus x. Commutative property says those are the same exact equations. So if you recognize that at this point, that hey, they have the same slope, they have the same y-intercept, this means there's going to be infinitely many, then you can go ahead and write down infinitely many. Otherwise, you're going to catch it when you graph it. Because if I graph my first equation of, okay, y-intercept of negative 8, my slope is, remember if you just see x, it means 1x, which is 1 over 1. So you go up 1, right 1, up 1, right 1, graph that. And when you go to graph your second equation, lo and behold, oh, the y-intercept's negative 8, the slope is 1, so up 1, right 1, up 1, right 1. It's the same exact line. So when you have the same exact line, every single point is a point of intersection. I would write down infinitely many. And actually write out those words so that you can recognize them later, because if you just write I am, you might forget what that represents. Okay, so again, same exact system, but I want you to see what happens when you use substitution and elimination to solve it. So here we go. Step 1, I need to isolate one of these variables, the x or the y, and this time I'm actually going to choose the x because I can just add a y to each side, and x will be alone. I don't have to divide by anything. So I end up with x equals 8 plus y. So if x equals 8 plus y, all I need to do is plug that in for the x here and solve. So 2y equals, I have 2 times 8 plus y, quantity of, minus 16 or plus negative 16. 2y equals, okay, 8 times 2 is 16. 2 times y is 2y. And okay, now this time the y's are on opposite sides, so in order to get them all on one side, I'm going to move this one over there. That means I need to subtract 2y. So I end up getting 2y minus 2y, which is 0. And I end up getting 16 plus negative 16 on this side. That's 0. Does 0 equal 0? Yes. So in the end, this statement is true. That's how you could recognize from substitution that, hey, there are infinitely many because the variables have canceled out, but that final statement is true. Okay, same thing with elimination. I know it might seem kind of crazy. Why do we have to keep doing the same equations over and over again? Well, because you don't know how you're going to solve it. You have a choice. You have 3 ways. I want you to be able to recognize it no matter which way you pick. Okay, so for elimination, this isn't exactly set up for elimination because this isn't ax plus by equals c form. So we're going to make it that form. So in this equation here, I need the x to be on this side. So I would add a negative 2x, add a negative 2x, and you'd have 2y plus negative 2x equals, on this side, you'd have a negative 16. And in my original equation, I have x minus y equals 8. Let's rearrange these two so that it's an ax plus by equals c form. So negative 2x plus 2y equals negative 16. That was that second equation, and my first equation I had was x minus y equals 8. So this right here is the actual system that we're solving once you get everything rearranged. And I'll change that to add a negative. Okay, so it's not set up just to go ahead and cancel everything right out. We have to pick one of these to multiply. And this is really a 1. I know that 1 times 2 is 2. So I'm going to multiply both terms, and this little constant over here, by 2. So rewrite your original, and then 2 times x is 2x, 2 times negative y is negative 2y, and 2 times 8 is 16. When you go to add these together, negative 2x, positive 2x, gone. 2y, negative 2y, gone. You're left with 0. Negative 16 plus 16, yep, that's 0. So because this statement is true, that means infinitely many. All right, so last one. This is just a nice little review of the one solution business because that still can take place. So with this first one, let's solve this. Let's solve this by graphing. Would help if you could see it. There it is. It's right on your papers too. Okay, so if we're going to graph this, this means I need to rearrange it into y equals mx plus b form. That means in this first equation, I need to add a negative x to both sides. So this first equation will become y equals 3 plus negative x. In this second equation, I would add a negative x to each side to start, and you get negative y equals negative 3 plus negative x. And to get rid of that negative in front of the y, remember it's a negative 1, I'm going to divide each term by negative 1, and I get y equals 3 plus a positive x. Now, in looking like that at this equation, you might say, well, hey, wait a minute, they have the same y-intercept. Isn't that something special? It had nothing to do with the y-intercept. It had everything to do with the slope. So you'll see when you graph these two, the first one, y equals 3 plus negative x. The y-intercept is 3. Having a negative x, that means it's negative 1, which makes my slope negative 1 over 1. So I'd go down 1, right 1, down 1, right 1, and draw my line. And in my next set, the y-intercept is also a positive 3. My slope is actually 1 over 1. Because remember, if you have an x, it means 1x. So from here, I go up 1, right 1, up 1, right 1, and draw my line. And we see that, hey, these lines cross at 0, 3. Now, some of you may have already seen that. Oh, hey, if they both have the same y-intercept, that means that's where they're going to cross. And you probably already knew, hey, it's 0, 3. If you didn't catch that right away, actually doing the graph will help you to see that. And remember, you can plug that ordered pair into both equations in the system, and it'll come out to be true. All right, so just a nice little review of substitution then. Here, I need to solve for one of these. So here, I'll solve for the y. That means I need to add a negative x to each side. So this first equation becomes y equals 3 plus negative x. We'll plug that in for the y over here. So I have x minus, remember, I need to have the quantity of, especially when these parentheses are in front of a subtraction sign. So it'll be 3 plus negative x equals negative 3. From here, I need to add the opposite of everything in there. So it actually becomes x plus negative 3 plus positive x equals negative 3. Combine like terms, they're on the same side, so I get 2x plus negative 3 equals negative 3. I am going to add 3 to each side. It's a regular old two-step. I do get 0 as a result over here. You are allowed to divide by 2. You can't divide by 0, but you can divide by 2. That's allowed. And we get x equals 0. That's totally fine. X is allowed to be 0. We're going to take that x equals 0 and plug it into one of the equations. I'll choose the top one. Remember that top one was x plus y equals 3. So if x is 0, 0 plus y equals 3, that means that y equals 3. So now you have your x, you have your y. We see that there's one answer. Same exact thing. Alright, last one, a nice review of elimination. This one's set up nice and pretty for elimination. That's probably the method that I would use to solve this one. I see that I have a positive y, I have a negative y. That's set right up to go ahead and cancel. So with elimination, this y plus negative y would be gone. I'd be left with 2x, and 3 plus negative 3 is 0. Divide by your 2. We get our x as 0. Plug it into the top one. 0 plus y equals 3. That means y equals 3. And you are done. See you tomorrow.